Hello everyone. Today we are going to implement add@index method in our DoublyLinkedList implementation. So format is same. First we will do a pair programming or coding, and then after that we will come back and we will execute some use cases. Uh, Today we will see a lot of new things in this method. This is a pretty amazing method. I really love to implement these kind of methods, and we will see once we are back on the whiteboard. Fun add index integer value t, or maybe we can do value first and index later. So this is our declaration of a method. Now it's time to write the definition. So in this case, these kind of I really love these kind of methods because here you can learn a lot of things. So we can start one by one. First, the most important part is edge cases. So in case of add@index, it means I'm going to insert a node in between of two nodes. So there are mainly three edge cases. One, you want to add in a start, so somehow you gave the index 0 most probably. Then you want to add in the end, and then the third one is in between. And in case if the client is giving you the wrong index, what should be the our approach? So in these kind of methods, I love to throw the exception. Yeah, because I'm expecting index should be given by the proper index should be given by the client. In case if it's not, we should throw the exception. So I'm going with the same. So the first thing we need to check index is index. So I can say check index position, and I will ask to this, and I'm going to make this method. Okay, so how we can show the index is valid? Po position spelling mistake. Okay, so I can I have a size variable, and I can find out by using that. So check index position. I will say if index is less than 0, it means it's a wrong index, or index is greater than size. Now here is a question, is it greater than equal to? So in case of an insertion, for example, I have 5 nodes and user asked me to put at index 6. So if you see, we have a size which is 5. In this case, in my opinion, it's a correct, because the client is asking, okay, put this in the end. So it means it's a valid input. It's not like it's going outside of. Yes, if I have 5 nodes and user gave us a 7, in that case I will say it's a wrong index. So what we can say, okay, if index is less than 0, then throw an exception, or index is greater than size. Greater than size means if I give the size, that will be okay. Or check index position, or what we can do, we can make a one more function is index valid. Maybe is index position valid, and that will return us the boolean, because we can use this method on many other places. So index integer, and I will return. So what will happen if index is greater than 0, greater than equal to 0, and an index is less than equal to size? it means it's true. So I took in, you can write how you want, but for me, so if the index is greater than or equal to 0, and so basically this is my boundary, 0 and size, my index should be in between, or maybe the start of the linked list, which is 0, or maybe the end plus 1. Basically in this case, again, if I have 5 node and index is 6, so in that case my size is 5, my nodes are basically 4, 0, 1, 2, 3, 4, because index starts from 0. So in that case 5 is equal to 5, yes, it means I'm going to add in the last. But if it's 7 or -1, it means it's wrong. Now this method here, now we can throw the exception. So we can say if is index of position is false, so if it's true, then there is no need to do anything. But if it's false, I will say it's true and throw index out of bound exception, and we can write index is invalid, and we can show also the size, and index $index. So this, or maybe what we can do, we can make a one more method, private fun exception message, and in that case I will send int and size I already have, so I can return string, and in that case I will copy this method, no, copy this string, paste it, so we can use at multiple places the same method. And now we can say, okay, exception message index, anything else. So first validation is done. I got an index. If index going inside, it's checking is index position valid. If it's true, do false, do nothing. If it's false, it means index is not proper, then do true, make true, and then throw index out of bound exception, and exception message index is invalid, and then we are showing the size also. Next is, at this point at line 78, we are 100% sure index is a valid index. Now what kind of cases we have? Index equal to 0, index equal to, sorry, this should be equal to 0, equal to last, then index between 0 and last, and there is a possibility empty, list is empty and index is 0. So I think these are the only cases. Now what we can do, you remember my philosophy, we can we should reuse internal methods which we already wrote in previous videos. So now we can figure it out. If first case is empty, in that case I can say add first or add last. How I know? So in that case, most probably index is 0, and check index position is saying it's valid because index equal to 0 and it's less than equal to size. 0 0 is 0, which means it's done. So add first, then we can do add first and return, then this case is done. After that we have some values, but index is equal to 0. In that case again I want to add first, so I think we can directly say index equal to 0. In this case what will happen, I don't care if it's an empty or there are already nodes, and then the value is 0, it means we need to add in a start, so this will be good. So this case is done. Then if index is equal to size, which means we want to add at a last. Hopefully this makes sense. So basically if I have, for example, 5 nodes and user 5 nodes means 0 to 4 and user give the index 5, which means size is equal to index, so we are saying okay, add last. So this one is complete. Then can we refactor this somehow? Because I remember in case of a add last we still call addFirst. Like for example, if index equal to 0, I call add last, and I'm assuming an add last is go there and it will check is empty. So that can work for the case when we don't have any node. But if we have node like 3 nodes and then I call add last, is empty, is not is empty, oh then there is a blunder. Okay, so currently this one looks like okay. Now the last case we need to manage now, that is, it means in between. So first thing, now at this position to save our, and then index between 0 and last. So how we can take care of this? So first I need to found that value in the index node, and that in that case what I need to do, I need to call while on a variable current is equal to head, and then I will say current, not current, I will go with count equal to 0, and until count is less than index I need to do current dot next node and count plus plus. So basically in this case what will happen, for example I have total 10 nodes, so my size is 10 and user give us 5, like I need to insert at index 5. Index 5 means it will start from 0. 0 is less than index, it will increase 1 2 3 until 4 is less than 5. Then it is a 5 index 0 to 5, and then it will come 5 is less than 5, no, so this will break, and now my current is the index and the node where I need to insert. Okay, so I need to create a new node first, and I need to put value. Okay, this is done. Now what I want, node dot next node, so should be current dot next node. So try to imagine what is going on. For example, I have a node 1 2 3 4 and 5, and according to the index I need to put after 3 the value 6, and my current node is 3. So basically in between 3 and 4 I need to add. So this is my 6, so this is my 6 node, this is my value is 3, and what I'm trying to say, basically dot next node is 4, and I'm saying okay, 3 a next node of new node should be 4, looks good. Then node dot previous node should be, I think so, current, we will see. So currently I'm saying this one is again 6, this one is 3, and what else? So my new node next node is currently referring to the current dot next node, so 6 to 4 and 3 to 4 both are on doing on the same. then my new nodes, the previous node is now attached with the 3. Then what I want current to override current dot next node should be 6. Makes sense? 3, and before that is going to 4, but now I'm saying uv should be 6. And then what else? If you see at this point how the links are, 6 is in between, 6 previous node is doing to current, and current next node is doing to 6. So at this point that one is done. Now there is still remaining one connection with the 4. In that case, what is remaining? So node dot next node is current dot next node, which is 4, and we need to do node current. There is looks like there is a bug, we will see. Okay, current dot next node dot previous node should be node, and this should be dot before this. Okay, we will try again. So if I do this on a whiteboard, we will do later, it will be pretty fast, but because I'm directly doing in a coding, it's taking some time for me. So we have a new node which has a value. We have a list which is 1 2 3 4 5. We want to add 6 in between 1 2 3 4 5, and this new node is basically 6. And then what I'm trying to do, 6, your next node should be 4, which means current is this, so current dot next node, which is 4. So I'm saying, okay, node dot 6, you are now here, maybe you are here, but now your next node is assigning to 4, and 3 is still assigning to 4. Then I'm saying, okay, node, your previous node should be current, which is 3, so 6 is done. After that I want first this line, yes, because current 3 dot next node, which is 4, dot previous node, which is before that, is going to 3. Now I'm saying, okay, you should update to 6. This one is fit. Then after that I'm saying, okay, current 3 dot next node, which is to 4, override to 6. And after this, I hope everything looks okay to me. We will see if there is any bug. So until this point, we are good. Maybe we can run first, and then we will back to refactor this. So first I will create a list of maybe 6, and I will say it plus 1, and or I can easily write it so everyone can understand. Add last 4 3 2 1 0, 4 3 2 1 0, or 0 1 2 3 4 and 5. Then output, now we'll run, and then we'll see first if it looks okay. So yes, 0 1 2 3 4 5. Then first check, I need to say, okay, list dot add value maybe 100 at position 0. Sorry, I forgot. So this should show, okay, it's working. 100 0 1 2 3 4 5 6. Then next I can ask put 100 at the position of the last node. So basically at this point we have how many nodes? It's 1 2 3 4 5 6 and 7. So I will say should be 8. Sorry, it's 7, because index, I'm giving an index, not the size. So it's 7 0 to 6. and now you can see until now we are doing good. So at start and at end, then in between, so in between I want index 0 1 2 and 3. So add at index 3. In that case, what should it show? It show uh, 0 1 2. So we will be here, and it should show. So the last one is not shown, okay, because I forgot to add the print statement. So now you can see easily we gave the index 3. In this case we are saying, okay, this one is 0 index, 1 index, 2 index and 3 index, and after at 3 index we are inserting a value after that, and it's 0 1 2 3, and now we have 100 and everything looks good. So it means our code is working properly. Then I can see there are first, the most important part again, I'm revising add first and add last. We can use easily the already existing methods, and this is a new method, a new code which we need to do. I have a feeling we can improve this place. So I think this is kind of a generic code, and I can move in the form of a method, and I can say get node at index, or maybe get node is enough and the parameter is giving us enough information. So every time when we call, because we can reuse this on many other places, so this is good, no big change. Then we created this. If we run again, still it's working. Should we try one more example? Okay, so again I want to, maybe I want to add at index 1. Index 1 and value should be 200. So in this case we are expecting it should show after 0. Oh, because we have this first is as due to this we already added this, so 100, then the index is 0, and then we have 200. So at this point we are adding the value basically after that index. So once I gave the index, okay, index 0 we put at this 0 index. If I'm giving the last index, it's giving the last. In case if I'm saying the index, there is a bug, the logical bug. So my expectation is, for example, I will remove all other, and I want to add list dot add. For example, I want to add at index 1. So index value 100, index 1. And I need to print. So in this case 0 is 0, 1 is 1, so it's look like we are adding after that index in case of when we are adding in between. But when I'm giving an index 0, it's working how we are expecting, like at 0 we are adding that, and same in the end, but in between there is a logical bug. When I'm saying okay at index 1, so my expectation is this one index should be, and in that case what we can do, so if basically in that case I need to send -1. So in that case, yes, so now you can see I inserted at an index on that index, so at 1. Now it's working properly. And is there any bug? So basically -1 can create an edge case, but we already handled here. So if it's 0, it will never commit, so it will never go to the negative. And now on the other side, we want to check this should crash at wrong information. Yes, then -1. Yep. So I think everything is working properly. We can review one more time if we can improve. So these are all private methods, helper methods to this class. We can move this in the end, and this one is an exception. In this case, if index is equal to 0, then add first, otherwise add last, otherwise size plus plus. And this will no more, because we are returning from there. Then in this case we can try to play. So if I say, so basically in this case I'm saying, okay, node dot next node is current dot. So I can improve this by using properly the constructor current dot next node, and we remember the third part is our previous node, so I'm giving to the previous this. So to me it look like this should work. So first at index 0, then I'm adding at this point we have 0 1 2 3 4 5 6 and 7, so it will go in the end. Then I will say okay, add at the position 2, and now we'll see by changing that is there any impact. So first, once we added at 0, so we have 100, 0 1 2 3 4 5. Then second we have already 100, and I added in the last, which makes sense now. Then in between I added at a 2. So at we already have at 0, which is 100, then 0, this is 0 1, and this is the index 1. And we want to add at index 2, 0 1 and 2, and yep, it's working how according to our expectation. It looks nice. So we improved little bit here. We are now using properly that constructor of our node method. Anything else we can improve here? So if I do current dot next node dot previous node is equal to node, no need to create this one extra, but in that case it we can, but that look more ugly, but we can try. So what I'm trying to say, like, so I will say, in my opinion, don't do this, but only for testing, this case should be worked. Then after that I am saying, once I'm assigning you that node, the same node I want to assign to this, because both are node. If you remember, the last one is this node and node, and if I run again, it should show everything looks like the previous one. Yes, so by doing that I will not create a new node and I will play like this. But I think it's pretty difficult from the readability perspective, and we are only saving 2 lines from the code, nothing else. So I will go with the previous implementation. So I think until this point this looks okay, minimum, and node current. So yep, I hope you enjoyed this. Now moving back towards the whiteboard to do the some time and space complexity analysis. Welcome back. So we will start with first with the edge cases. So what kind of edge cases are there? Or maybe first we can finalize the definition and the declaration maybe of our method. So our method will be like, looks like this: fun add value, which will be t, and then index, which will be integer. So that is our method. And add at index means basically we want to implement or kind of insert in a linked list. What kind of edge cases there will be? So we already discussed. I will go pretty fast. First edge case we need to think about, or maybe we can start in the form of a use case. So this is our main method. our client created a doubly linked list. So first use case will be it's an empty linked list, and client decided to do add maybe value 1 at index 0. So in this case, what will happen when we executed this, it means I have their head which is currently assigned to null. Okay, then after that, as you guys remember, when we implemented, when we are saying index 0, we have a check. First check is the exception, so it's not an exception, it's a proper valid input, and in that, inside of that, once the check is passed, validated, we are checking if index is 0, call our addFirst method. So in that case, we will call our addFirst method. I'm not going to discuss about the addFirst method, but you can watch the other video where we implemented addFirst. So in that case, every time in addFirst, we will create a new node, assign the value, change the head like this. So this one is the first edge case we need to tackle when it's empty and we did add at index 0. What's next? Okay, again, client again invoke the same with 2 0. In this case, in our implementation, just like we did, we are saying again, if the index is equal to 0, call addFirst. So in that case, again this will call addFirst. Inside of addFirst, we create a new node, we will assign this value to 2, we will change head to this, we will give head this new node to this, and it's previous to this. So until now, everything is working with this first use case. The second use case, the edge case or a use case, I want, or clients want to add a value in the end, 0 1 2. End means the number of elements, total number of elements. So in this case, we have size equal to is 2 1 2, and we index 0 and 1. So in this case, user is saying, client is saying, I need to add 3 at 2. So at this level, we have size 2, but index is 0 1, so this is 2, which makes sense, and that's why we are calling add last inside of our implementation of this add method. Before going to implement, I want to show only one more thing. So for example, client say add 3. So in that case, what will happen? We have a 0 index, 1 index, there is no 2 index, and we are calling 3. And in that case, our check validation will throw the exception. So 2. So now we can execute. In case of a add last will check if it's empty, then call the addFirst. Otherwise, add last have a tail, and then tail will do what? It will create, and first it will create a new node. Then before that, tail is here. It will move like this, previous like this, and tail will move to this. And now we have 3. So this is the second edge case, not edge case, it's more like how we are reusing our methods. And this will change to 3. Until now we executed 3 edge cases, when is empty, when is the first, and when is the last. But now we are going to implement the real method means we are going to insert in between of a list. So for example, we have a linked list with 2 nodes for now. Like the same logic you can apply at any number of the nodes, but for now I have these 2, and clients say, okay, you want to put 3 at index 1, so 0 and 1, it means in between we need to put. And to make sure we really understand what we are doing, I can write that code which we already implemented in the coding part. So we have a current node which we get from the get node by doing index -1. Then after that, what we did, we need to create a new node, and and that is the node, and we put value here for, in this case, 3 for example, hard coded. Okay, I can also draw some. So this is our current node, Cn. And because index is 1, 1 minus 1 0, so this is our current. Then I'm going to create a new node. So this is our new node. Then this one is n. What's next? What we want, basically we want this to move this from previous to this, and then the same here. So for linking, what we did, we are saying, okay, node, your next node. So basically I'm saying this one, where should this go? This should go to this, which is currently current node dot next node. So first thing is done. Good. Then n dot previous node, what should we want to do? We want to go to this, and this is our Cn. Nice. So now we have now proper links. Now what I want to break this, and I want to assign to this. So it means what I can do, I can say, okay, current node dot next node equal to n, or I can say current node dot next node. So current node dot next node, now we are here, your previous node means this, move to node. So in this case I'm saying remove this link and go back to this, and then in the end the last one is current node dot next node is equal to node. So basically I'm saying your next node should assign to this, and now we have a proper doubly linked list. So don't memorize this code, you need to only understand this. Can I do this thing in a different way? Yes, I can do. So like before that, I'm going back to this and only showing you, don't memorize, try to understand the steps. It's pretty easy once you do the practice on a paper. So I don't want to go with this approach. Okay, basically what we want, I want this previous node to go to this and this next node to go to this. So for example, I can say, okay, this line does not look nice to me, I removed. Okay, so in this case, after this we're saying, okay, Cn dot next node should go to node. So this one is done. Now I need to access this previous node. How I can access? I don't have a current node dot next node more, but I know node dot next node. So I can say, okay, n dot next node. So n dot next node, this one, next node, your previous node, this one should be node or n node. Basically n means node. So in this case, what will happen? I took from n, next node is here, take your previous node, this one, and assign to n. So you can play with this and you will start feeling comfortable with this. So I hope I share with you something new. And is there anything we can discuss from the memory, space and time complexity? Yes, we can. So basically the case, in a worst case scenario, what will happen? We have a kind of a second last index. In that case, get node needs to move until second last, and then from there, this is always a constant operation. But in that case, we can say it's a big O of n. There are like in for example, in my case, assume we are aware of most of the time when we are doing insertion, we mostly do insert on a second first node like index 1. So I'm only making a hypothetical scenario. So this doubly linked list scenario is specific to some one specific use case. In that case, we have this list 1, 2, 3, 4. So this is our list. And in this scenario, 95% in that use case, every time when we do insert, we always do insert 99%, not 100%, at index 1 or at size -1 or second last index. So I can say first or second last. In that case, first index means this, because this one is 0, this one is 1. So every time once we have an index 1, I will check that, and it's always a 1 operation. It will never complete the big O of n. It's only take heads next one. So it's always a constant operation, big O of 1. In this case, second last, we can get the benefit from the tail. So I always say, okay, tail, give me your previous node, which give me this. So in this case, head dot next node, and in this case, previous dot. And then after that, I need to insertion around this. So I can make this is a big O of 1 operation. But again, this is a hypothetical scenario, but you can play by doing multiple things, and then you can really understand how to manage the time and space complexity. Don't try to memorize, okay, because there is a while loop, it's going to this. Ask questions to your own self. Okay, if there is a hypothetical scenario, can I make this a big O of 1? So this, you need to think like, okay, I want to make this method big O of 1. I don't care about the production code or what is going on in reality. Then figure it out. Okay, how to make this big O of 1? Maybe hypothetical useless dump scenario, just like I created, and then put that. So by doing that, you will really understand, okay, what you are doing. That is called analysis. Not by memorizing, okay, if it's a linked list, it's a big O of 1, if it's add, if it's last. That may create difficulties when the interviewer will change little bit things around here and there, and they want to really understand, are you memorizing things or not. So yep, that is complete. See you in the next video. Bye.